Hey class, hope you're doing well. So right now we're going to go over the notes for lesson 3.3, and here we're covering something called the discriminant. So let's jump right into this. First of all, a bit of review. If you have an equation that looks like this, ax squared plus bx plus c, it's got the x squared term, the x term, and it's got the constant term, then we have to make it equal to 0 and then factor. But factor if you can. If you can't factor, then use the quadratic equation, which we reviewed, was on the quiz. If you got something like this, ax squared plus bx, your x squared term, your x term, but no constant, then these guys will always factor, and what's more, one solution will always be 0. Okay, if you got something like this and this, then you're going to be taking the square root. Probably easiest to take the square root of both sides. So let's just warm up with something like this. 2x squared, 4x minus 1. Now, this might factor, but whenever the coefficient here isn't 1, I like to just use the quadratic equation. So a is 2, b is 4, c is negative 1. We're going to plug those in here. Remember, the quadratic equation is negative b plus or minus the square root of b squared minus 4ac all over 2a. So where I see this spot right here, we're going to put in 4, that's our b. And then right here, b shows up again in this spot, so I'm going to put another 4 here. And then a is 2, c is negative 1, all over 2a, and a is 2. Okay, so just cleaning this up a little bit. Negative 4 plus or minus the square root of 4 squared is 16. Here we've got a negative and a negative. Negative times a negative, negative is going to make a positive. 4 times 2 is 8. And then all of that over 4. Okay, cleaning this up a little bit more. Negative 4 plus or minus 16 plus 8 is going to be 24 all over 4. And we could simplify it a little bit more, but let's just leave it at that for now. Okay, so let's talk about square roots one more time and about imaginary numbers. Let me just go up here. Okay, so let's suppose you wanted to make a building that had an area of 16. Then you'd want to do 4 and 4, because 4 times 4 is 16. If you had an area of 25, you'd want to do 5 and 5, because 5 times 5 is 25. What if you had an area of negative 1? Then you'd want to have something times something equals negative 1. Something times something equals negative 1. Now you might think immediately that negative 1 would work until you realize that negative 1 times negative 1 is positive 1, so that doesn't work, and obviously 1 doesn't work, and so there's actually no number that'll satisfy that. So because there's no real number that answers this question, we invent a number and we call it I. I stands for imaginary. So let's say we had some equation like this, x squared plus 1 equals 0, and we wanted to solve it algebraically. Then we would subtract 1 from both sides. That's going to give us x squared equals negative 1. Then we take the square root, we take the square root, and so x is equal to the square root of negative 1, which again we define as I. Now, let's talk about why there are no solutions here. If I was to graph y equals x squared plus 1, then it's like my good old friend y equals x squared. This is y equals x squared, except it's been lifted up by 1, so it looks like this one in red. Now, when I set the y equal to 0, I am asking this question: what value of x will give me a y value of 0? In other words, where does this graph cross the x-axis? And you can see, no matter what value of x I'm tracing, I'm never going to cross this line. This is the x-axis. And the x-axis is also the line y equals 0. So it's never, ever, ever going to cross this line. And that's why if we ask it this question, 0 equals x squared plus 1, we're asking it the impossible. there is literally no value of x that's going to make the y value drop down to 0. Okay, so not every quadratic equation will have a solution. Here is a prime example of a quadratic equation that has no solution. Now, solutions are synonymous with x-intercepts. This graph has 2 solutions because it has 2 x-intercepts. This one, two solutions, 2 x-intercepts. This one right here in red has 1 solution because it has 1 x-intercept. Okay, let's go and look at the back of this page now. Okay, so if you are solving a quadratic equation and you get some kind of imaginary number, then that's math's way of telling you the x-intercepts only exist in your imagination. In other words, the only solutions that exist are imaginary. There are no real actual solutions. I'll give you an example of it right here with this guy. So A is 1, B is -6, C is 25. Quadratic equation is negative b, so negative 6, because b is -6, plus or minus the square root of b squared minus 4ac all over 2a. And so -6 is +6 plus or minus 36. And here, 4 times 1 times 25, that's going to be 100 all over 2. And so that's going to be 6 plus or minus the square root of 36 minus 100 is going to be 64. But it's not really 64, it's actually -64 all over 2. So we can't take the square root of -64. We can't take the square root of negative anything. Y, let's just look at y, that is. If I wanted the square root of -64, then I would want 2 numbers that multiply together to equal -64. But we know that can never be true, because if that number that I chose was a negative times a negative is a positive. If we chose a positive, then there's no way we get the negative sign. So this is an impossible kind of situation. There are no real solutions. Okay, there are only imaginary solutions. So let's talk about a property here with imaginary numbers. How do I simplify something like the square root of -64? Well, here's a property. If you have something like this, if you have a negative under the square root sign, let me zoom in. If you've got a negative under the square root sign, you just pop out the letter I. Okay, let's do that with this example here. I've got a negative under the square root sign, so I pop out the letter I, and now I just proceed like I normally would. Just ignore the I for a second. Square root of 16 is 4, so this is I4. Now, just by tradition, we write this as 4i. I don't know, I guess because it looks better that way. Okay, let's simplify this one. There's a negative sign under the square root, so we pop out the letter I and write this 8. Now 8 is the same thing as 2 times 2 times 2. I'm looking for groups of 2. One of those 2's pops out, and so the final answer is 2i square roots of 2. Okay, let's look at this. Square root of -20. We're going to pop out the letter I, square root of 20. 20 is the same thing as 2 times 2 times 5, is that right? 4, 5, yeah, I think that's right. And so now 2 of them, 2 2's, so one of them pops out, 2i square roots of 5. And finally this one, negative under a square root sign, that means the letter I pops out. And we've got 18, 8 to the 4th. And 18 is 9 times 2, 9 is 3 times 3, and then 8 to the 4th, 4 A's. Okay, so group of 2, group of 2, group of 2, a 3 can come out, an A can come out, another A can come out. I have my I there, and the only thing left under here is that sad little 2 that has no friends. Great. Okay, so that is simplifying square roots with something negative under them. The key here is to pop out the letter I. So let's go down now, and we're going to apply this now to our friend, the quadratic equation. Now the quadratic equation is this thing right here. Let me just clean up some of my writing. There we go. Let's zoom in right here. So the quadratic equation is this thing. Negative b plus or minus the square root of b squared minus 4ac over 2a. So what would have to be true about the equation for there to be imaginary numbers, for there to be imaginary solutions? Yeah, to get imaginary solutions, this part, the part under the square root sign, would have to be negative. So to get something imaginary, just that part of it, b squared minus 4ac, is negative. And if that's negative, then we're going to have some imaginary solutions. Now, this bit right here, b squared minus 4ac, actually has a special name. The special name it has is the discriminant. Okay, so let's talk about this. Here, if the discriminant is negative, then we're going to have 0 real solutions and 2 imaginary solutions. Now, why is this? Let's just go through this really quick. Why do you end up like that? It's because quadratic equation, negative b plus or minus square root of b squared minus 4ac all over 2a. Now, if this whole thing is a negative number, let's just call it negative 7 or whatever, then that is going to turn into I square roots of 7. And there are 2 solutions here, right? Why are there 2 solutions? Because it's negative b plus I square roots of 7 over 2 and negative b minus I square roots of 7 over 2. So you've got these 2 solutions. Both of them are imaginary because they have that letter I in them. Now, graphically, what this looks like is something like that or something like that. You can see that it never, ever, ever touches the x-axis. So in other words, there is never a point where the y value of these things equals 0. There's no real solution. Okay, let's give an example here. So here we've got this equation right here, x squared plus 2x plus 3. Now, we're not interested in finding the solution to the equation if it's set to 0. We just want to know how many real solutions, how many imaginary, all that stuff. So we're going to do this b squared minus 4c. First of all, our a is 1. There's a 1 there. Our b is 2, and our c is 3. So let's plug those in here. Instead of b squared here, our b is 2, so we're going to do 2 squared minus 4a. Our a is 1, and our c is 3. So 2 squared is 4. 4 times 1 times 3 is 12. 4 minus 12 equals negative 8. So the discriminant is negative 8. So in our example down here, it would be like having that kind of thing going on. And so you'd have 2 solutions. Both of them would have this I in them. And the reason we have the I is because there's a negative under a square root sign. And once again, if you got a negative under a square root sign, you pop out the letter I. There's no real solution to this. You can never get something real that's a negative square root. Okay, let's go now and talk about some of these other possibilities here. Okay, the other possibility is you might be doing the quadratic equation and you get the discriminant is equal to 0. Now, how does that affect your equation? Remember, the quadratic equation is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, if this part, the discriminant, is 0, how does that transform our equation? Now we've got negative b plus or minus the square root of 0 over 2a. Well, the square root of 0 is just 0. So again, this is just going to be negative b plus or minus 0 over 2a. And that is the same thing, breaking it apart, is negative b plus 0 and negative b minus 0. Well, we can just forget the whole plus 0, minus 0, right? And so we really just have one solution. And our one solution is just that negative b over 2a, right? Okay, so if you've got the discriminant equal to 0, then in that case, the number of real solutions is 1, number of imaginary solutions is 0. And what does it look like to have one real solution? Well, that means it touches the x-axis at exactly 1 point, like that. So it looks like either of those cases. It touches it at exactly 1 point. Okay, doing a concrete example here. A is 1, B is 2, C is 1. So 2, 1, 1, 4 minus 4 equals 0. So in that case, only one real solution because the discriminant's 0. Okay, last case is the one we're most familiar with, is if the discriminant is positive. So an example of this, 1, 2, -1, and we're going to plug those numbers in here. That's going to be 4 plus 4. It's going to give me 8. And so if I put this into the quadratic equation, we have negative b plus or minus the square root of b squared minus 4ac, which is 8. So that's just an 8 over 2. So two different solutions then. Negative b plus the square root of 8 over 2, negative b minus the square root of 8 over 2. Now, it doesn't really matter what the square root of 8 is. You know it's going to be a crazy decimal, but this whole thing is a crazy decimal. This is another crazy decimal. We don't care that it's crazy. We just care that it's real. These are two real numbers. And so we have two real solutions, and we have 0 imaginary solutions. Now, let's say the discriminant is some perfect square, like negative b plus or minus the square root of 25 over 2. Or negative b plus or minus the square root of 36 over 2. Now, in that case, we won't have a crazy decimal because the square root of 25 is just going to be 5. And the square root of 36 is just going to be 6. And so now we have two rational solutions. So rational solutions are numbers like 5 or 1/3 or 0.2 or 0.33333, right? These are things that we can either write as simple fractions or simple decimals. Okay, so if you end up with something that's rational, that means that, if you end up with a perfect square as your discriminant, then your answer is rational, and it also means that you could have factored it. Had you been doing this a different way, you could have factored that. Okay, so let's go ahead and draw this out. So this looks like this, two real solutions, or like this, two real solutions. Okay, that's it.